Snakes. For over 100 million years, they have slithered their way across the face of the earth. But recently, they have conquered a profoundly different environment. The ocean. That invasion has taken place in the blink of an evolutionary eye. Now, over 50 species of these cold-blooded intruders have colonized the world's tropical seas. Feared by bathers and divers, their venom is among the most toxic of any creature. But much about them is a mystery. What made them abandon the land? The search for clues leads to an extraordinary place that is the sea snake capital of the world and reveals the very private lives of these serpents of the sea. It's as if the sea snakes appeared overnight. Their origins remain shrouded in mystery. The best guess is that they evolved from land snakes about 5 million years ago. Those that have been studied, like the yellow-lipped sea crate, remain shy and secretive. Sea krates are known from coastal Asia to the Pacific and are most easily found in the waters of Fiji. Mambualau is one of the small uninhabited coral cays of the island group. The warm, shallow waters provide a rich hunting ground for marine predators. Although they have abandoned the land, the sea krates have kept some reminders of their earthly past. They are air breathers. But a few quick breaths are enough to sustain 30 or 40 minutes stalking among the coral crevices. To most reef fish, sea krates pose no threat. Eels are what they seek. Near the surface, they're vulnerable to sea eagles. In defense, the sea krates employ a unique kind of camouflage. The bands on their skin create an optical illusion. They appear to move in the opposite direction to the snake itself. In the moment of confusion, the snake can escape. As well as breathing air, the sea krates have retained other legacies from their terrestrial past. When not hunting, they must return to land. The rugged coral of Mambualau is the first obstacle they meet on their mission. The coral is not just dangerously sharp. Around much of the island, it forms vertical faces and overhangs. But as well as being expert swimmers, sea krates are excellent climbers. The struggle is vital. Spending time ashore is the only way that these cold-blooded creatures can get enough warmth to digest their food. The journey exposes them to more predators. Many snakes find the journey exhausting. Along the way, ticks burrow beneath their scales. They will stay attached even in water. But like the hermit crabs that find new shells as they grow, the sea kraits replace their skins and shed their parasites every 4 to 6 weeks. They take these pains not just to get warm, but to satisfy one other undeniable need for the land. This is where they must come to lay their eggs. Like the snakes, their eggs too must breathe. These ties to solid earth have cost the sea kraits dearly. There are just 5 species of these amphibious serpents. Their cousins, the true sea snakes, made a far more successful transition to the ocean and are much more numerous. The story of that transition is still being pieced together. It begins on the continent of Australia. Sea snake evolution began here long ago, in the dry north. This is the environment their ancestors came from: dry scrub and desert. Reptiles were made for this harsh land. While the abundant sunshine is a free source of body heat, their waterproof skins protect the body's precious moisture from the air. But one more thing has helped Australia's reptiles to multiply. The tropical warmth is ideal for incubating eggs. If the temperature cools, pythons can insulate the clutch with their bodies and even shiver to ensure a steady temperature for the developing young. After 2.5 months of careful incubation, the eggs hatch. From this moment on, young snakes receive no more parental care. 20 million years ago, venomous snakes arrived here. The taipan is the second most venomous snake in the world. One bite from an adult can kill 20 people. Even very young taipans are lethal. From the moment of hatching, they're armed for the kill. The snake's meal is being digested even before it's swallowed. Without fossil evidence just how venomous. One of them can be found in northern Australia's coastal swamps. Here, a rich supply of prey is offset by a challenge that faces all terrestrial invaders. The white-bellied mangrove snake specializes in eating crabs. The venom these snakes brought with them from the land was an important weapon against these resilient creatures. just where to inject it on the armour-plated body is a minor problem. The soft elbow joint of the claw is the easiest target. Once the crab has been secured, more bites will go through its hard shell and the poison does the rest. But the snake also risks being poisoned here. Every time it swallows, salt from the water accumulates in the snake's body tissues. To answer this challenge, these serpents of the shallows have modified their salivary glands, enabling them to spit out the excess salt. But the true sea snakes made one more modification, and did so before they even took to the water. It's thought that the change came at a time when global temperatures fell, making the incubation of eggs more difficult. In response, snakes like the red-bellied black snake, which live in the cooler parts of Australia, developed a new breeding strategy: live birth. Live birth enables the mother to warm the developing embryos right up to the moment of delivery. Released from the egg, some snakes took to fresh water, some to coastal shallows, and some directly to the sea. Free of the land, the sea snakes were never to return. Unleashed into Australia's tropical oceans, they have prospered, diversified, and spread from Asia to the Americas. Right in the heart of their distribution lies a place that harbours more species than anywhere else. 500 miles west of Darwin are the islands of Ashmore Reef. A voyage to remote Ashmore is a venture into the lair of the sea serpents and a chance to see their evolution in action. Few have ever studied the sea snakes, but they are zoologist Mick Guinea's passion. It's a 3-day sail. The doldrum season will provide a 5-week period of calm to safely visit the reef before the tropical storms arrive. Ashmore is a protected nature reserve where life is dictated by the forces of ocean and sun. 3 tiny islands sit atop a reef complex 15 miles long. One side receives the brunt of the Indian Ocean's waves and weather. The sheltered lee side is calmer. In the reef shallows, water temperatures reach 95 degrees Fahrenheit. Mick and assistant Scott Whiting must seek out an area for study. What they need is a small patch of reef that offers the greatest diversity of habitat. They employ a manta tow to survey the complex. Plains of sediment support huge beds of seagrass, attracting grazers and with them, predators. Coral outcrops called bommies are dotted around like apartment complexes, offering food and shelter. every part of the coral abounds in life. Everywhere there are sea snakes. At least 17 species inhabit the reef. Ashmore really is the sea snake capital of the world. The bounty of the area has long been known to fishermen, but other visitors are rare. This is Mick's third visit.
Well, there's few places in the world where you could dive with so many species of sea snakes and so many sea snakes of each species. It really is a wonderland for any scientist.
By day's end, he's chosen a coral bommy around which to base his studies, and the next phase of research can begin. To find out how territorial the snakes are, Mick and Scott must identify individuals. But first, they have to catch them.
The natural history of the sea snakes really isn't known at all. It's only by spending time with them, observing them, following them around and doing some very elementary tagging work that you can actually build up a natural history for them. There's a great gap in our knowledge of understanding just how these snakes fit into the environment and their place in nature.
What makes Ashmore such a haven for sea serpents? And what is it about them that lets so many species coexist? Most of what is known about sea snakes comes from lab studies. Their isolation and dangerous reputation has meant that their behaviour in the wild has gone unexamined. More is known about the lethal chemistry of their venom than their disposition to use it. Although resting snakes are easily caught, they're still not happy to be bagged. Despite the risks, Mick has a relaxed attitude. Since starting his studies on the sea crates 20 years ago, he has never once been bitten.
I've always had the approach that they're not harmful and that they're not likely to hurt me, bite me or do anything of that nature.
While some species can be aggressive, the ones they've bagged aren't. It's just as well, because the job calls for some intensive handling. Although their markings appear distinctive, there can be a great variety of pattern and colour between individuals of the same species. It takes an expert to determine details like the species and sex of a particular snake. Once they've been identified and measured, a small plastic tag is attached beneath the skin. It's a harmless procedure, and the coded tag will allow them to identify each snake in the water.
By placing them back on the same bommy, I can see if the snakes are going to be faithful to a particular territory or if they're going to move randomly over the reef. So if I come back in 12 months' time and find that the snakes are still sitting on the same bommy, then I can be reasonably assured that the snakes have been there over the intervening period.
Ashmore isn't just a wonderland for scientists. The islands that sit atop the reef are also an important landfall for many birds, locals and migrants alike. Large numbers of crested terns breed and raise their chicks here during the calm spell. They're joined by many other species, such as noddies and boobies. A sample of snakes tagged. The rest of Mick's time will be spent following and observing the behaviour of the different species in his study area. One of the most common varieties at Ashmore is the olive sea snake. At up to 5 feet long, they deserve some respect. Although their venom is lethal, these creatures are reluctant to bite. It is their grace in the water and their adaptations to it that elicit admiration. The gentle undulations of their body and their flattened paddle-like tail combine elegance with efficiency. A row of flattened scales along the belly serves as a keel, stabilizing them as they glide through the water. Red bass or sharks occasionally take juveniles, but with few natural predators, it would appear that the adults have no need for an aggressive nature. As much as 20% of their oxygen comes from the water via their skin. The rest comes from the air, but just a few quick breaths are sufficient. The nostrils seal during dives. A single lung stretches for most of the snake's body, holding enough air to sustain them for nearly an hour whilst active, or 2 hours at rest. They are also extremely inquisitive. Divers have often mistaken this for aggression.
They're very curious snakes. They're very visually oriented. They see things shiny. They detect movement. They detect contrast very well. It's their curiosity, I think, that people often misinterpret as being aggression. They swim right in to investigate something thoroughly, and of course the way they perceive their environment is usually by the sense of touch and also by taste, and so they're usually not happy with something unless they've been able to taste it, and so that involves tongue flicking. So divers and equipment in the water, it gets a very thorough checkout by these snakes, just exploring the environment, just out of natural curiosity.
Olives are generalist feeders. Unlike the rays that forage exclusively in the coral sediment, they take a range of small prey from different parts of the reef. Their eyesight is good, but to truly identify a food item, they must get close enough to taste it. The snake is attracted to dark patches on the reef. In the dim light of the crevice, the snake's forked tongue comes into its own, providing a stereo sense of taste, just as in the land snakes. Not every hole is occupied, but the olive's innate curiosity will eventually turn up something. Sometimes it's an unpleasant surprise. but prey is plentiful at Ashmore. When a victim is found, it's time for venom and fangs to do their work. After one or more strikes, the snake will secure the fish with its body while paralysis takes effect. Without limbs, it can't hold the fish steady as it swallows. Instead, the snake separates each side of its jaws and with its fangs begins to walk its way up the fish's body. This injects venom into more of the fish, and the enzymes it contains begin the job of digesting the flesh. One good meal may be enough to sustain an olive sea snake for a week, but like so much else about them, exactly how often they must eat is a mystery. Many of the other species are specialist feeders. The horn-headed sea snake hunts across the sediment flats, investigating the sandy burrows of the local shrimps. But it's not the shrimp the snakes are after. It's the tiny gobies that associate with them. Many burrow-feeding snakes have developed slender heads and necks to work their way into the deep holes. This species has spiny scales. Perhaps they help gain purchase and squeeze down the hole. Despite its fierce appearance, this snake's intrusions are not always successful. Instead, it's an underwater game of cat and mouse. In the murky burrow, it's impossible to see. Once again, the snake's sense of taste is its guide, along with vibrations from the retreating goby. This time, its fangs find their mark. The prey is taken to the surface. Maybe swallowing requires a helping hand from gravity. In the endless routine of the doldrums, one factor imposes a daily rhythm on all reef dwellers: the tide. Twice a day, the snakes take their leave as the area is flushed of water. At its peak, a current of 9 knots drains the reef. But not all of the snakes retreat with the tide. As the exposed shallows receive the full blast of the tropical sun, air temperatures can easily surpass 113 degrees Fahrenheit. The leaf-scaled sea snake actually seems to prefer these conditions. By articulating its scales, it manages to draw water up and over its body, cooling it by a process of evaporation. Why should it endure temperatures that would kill most other creatures? It's another sea snake puzzle waiting to be solved. Just like a land snake, these serpents too must shed their skin. The warm water and abundant sunshine promote a vigorous growth of algae all over the snake body. By the time it's ready to shed, the protective eye scale becomes clouded. The loss of vision and algal fouling become an increasing irritation. The skin begins to peel from the lip scales back. To hasten the process, the shedding snake rubs against rocks and coral, trying to catch the old skin on a protruding object and peel it off like a stocking. Depending on the health of the individual, skins may be shed every couple of weeks or perhaps months. How snakes spend their days may be mysterious. But how they spend their nights is doubly so. It's Mick's first night dive at Ashmore. He has no idea what he will encounter. There are plenty of sleeping fish. But where are the snakes? Snakes usually active during the day are asleep. But other snakes are very active. These are the same ones seen sleeping during the day. Ashmore is indeed a 24-hour operation, and the snakes work in shifts. Could this be how so many coexist here? Not all of Mick's time is confined to the Bommy. Occasionally, he makes the long trip to the outer reef, on the edge of waters 600 feet deep. Life on the outer reef is just as diverse as the inner, but the proximity of open water means different creatures may be present. This also means different snakes. And Mick finds one that he holds a dangerous fascination for. Stokes sea snake.
I think all the sea snakes should be treated with caution. The Stokes sea snake I do treat with caution and respect. It's an impressive snake. When you see it underwater, it looks like a snake about its business. It's a snake that's got fangs long enough to penetrate a wetsuit and penetrate gloves. It's of a size that it's not easily restrained, and it's got very potent venom.
Not only is Stokes large enough to demand caution, it can have an ugly temperament, and when provoked, bites repeatedly. Even their choice of prey enhances their reputation. Stokes eat members of the scorpion fish family, the most venomous fish in the sea. To upset a Stokes is to invite fatal consequences. The breeding birds have made good use of the plentiful fishing, and the young are growing rapidly. For the migrant species, it'll soon be time to depart and avoid the cyclone season. Underwater, the constant warmth means there are no seasons. Sea snakes mate and give birth all year round. The courtship ritual of two turtle-headed sea snakes has caught Mick's attention. Nearby, a pair of olives has also begun to court. Since olives tend to cover more ground, Mick decides to stick with the turtle heads. The process is driven by the male, vying for the female's attention and trying to prove that he's a suitable candidate. In such graceful animals, courtship becomes an enthralling, sinuous dance of great charm and sensuality. Rival males will be attracted by the activity. It then becomes a test of who can hold their breath the longest. As more males are attracted, the dance becomes a serpentine orgy.
Several males will be courting a female at once. Now, it's not known whether she's giving off a particular chemical scent or an odour or what they'd call a pheromone, but the males are definitely attracted by this activity, and so it's not unusual to find 3 to 6 males courting a single female.
But in the end, there can be only one. Perhaps wearing the female out proves him to be a proper suitor. But it doesn't appear to be the whole story. This vigorous nudging is new even to Mick and has never before been filmed. Its significance remains unknown. The pair leaves the scientist on the bommy, preferring to keep the final act of their courtship a private affair. But the olives have returned and reveal this most intimate of efforts. Footage of this behaviour is also a Discovery Channel first. It is now the larger female who is in control, and the attached male is dragged around the reef according to her whim.
It would definitely be described as a very special moment to sort of see 2 snakes entwined, courting in the water, and having to breathe and still act as one snake throughout their courtship. It's one of the things they have to do that the land snakes don't really have to worry about.
Mick notices a dusky sea snake swimming nearby. The slight bulge in her abdomen tells him it's a pregnant female. Birth remains a secret. It's thought that expectant mothers hide in the shallows, but until that time, they can still be seen around the reef. At 8 to 10 months, the sea snake gestation period is far longer than any land snake. Exactly why remains to be studied. The gathering clouds signal the approach of the storm season. During their brief visit, Mick and Scott have observed behaviour that has never before been seen. The studies they've made over the past weeks may be elementary, but they have shed much light on the lives of sea snakes. Analysis will come later, but some early conclusions can be drawn. The sea snake's amazing adaptability not only let them colonise the sea, it also enables so many of them to coexist in a small area. By specialising in types of prey, territory and time of day, the different species at Ashmore can overlap one another without undue competition. Perhaps more importantly, the 2 biologists have been able to show that these creatures are much less aggressive than popularly thought. During his time here, Mick has even adopted one species as his favourite.
There's an ever a species that doesn't deserve a reputation as a dangerous animal, that would have to be the turtle-headed sea snake. It's got a rather an appealing look to it. They've got large eyes, they've got this large scale on the upper and lower jaw that actually makes them look like a turtle, and therefore they've lost their fearsome look.
There's another good reason for Mick to feel an attachment to the turtle-headed sea snake. This docile little snake shows evolution in action. Reef fish are agitated by its presence, but they're not intimidated. That's because the snake has all but dispensed with its traditional weapons, and instead of eating small fish, has developed a taste for their eggs. Mick has discovered that the turtlehead has replaced its fangs and venom with a specially adapted scale on its jaw for scraping tiny fish eggs from the coral.
Here you have a snake that's really evolved into a very sophisticated fish egg feeding species. It's taken the sea snakes in a new direction.
The turtle-headed sea snake could just be the beginning of a whole new family of reptiles. Sea snake evolution is very much a work in progress. But Mick's time here has come to an end. Like the other visitors to Ashmore, it's time for he and Scott to leave this isolated patch of land. The work will continue, analysing the behaviour they've seen and planning the next visit. But on the way home, they spot another ocean wanderer and are keen to get a closer look. Most sea snakes are confined to the coasts and reefs where they hunt. To see one in deep water is a rarity. The yellow-bellied sea snake hunts on the surface, ambushing the small fish that mistake it for driftwood. Agile, aggressive, and highly venomous, they're seldom seen near shore. They are also taking a new evolutionary direction, giving up the security of the reefs for life in oceanic waters. As a result, they drift in the warm tropical zone that stretches from South Africa all the way to Panama. These ocean voyagers may even encounter more humans in the future. A rise in sea temperature is all it would take for these snakes to widen their distribution to more populated areas like the California coast. Such a warming may indeed be happening. Another possibility is that via the Panama Canal, these snakes could reach the Caribbean and the Gulf of Mexico, where they would surely thrive. In a changing world, these serpents of the sea are capable of almost anything.